Good morning. Sorry that I could not be here today. Just a reminder that on today's assignment, which will be A4, you are required to do the EOC question number 2, which is this one. So notice there are no parallel lines, but there is a triangle, and you should be able to use that triangle to figure out what you need to find. You will need a compass and you will need a straight edge for today's lesson. It's going to be all constructions, and some of these constructions are going to be really cool constructions. All right, so let me talk about what it means to be inscribed and circumscribed. These are two words that you're going to need to know the difference between. Inscribe and circumscribe. The easiest to really look at from the way it's spelled is inscribed. So whatever you're inscribing is inside another figure. So if you're going to inscribe a circle, that means the circle will be inside whatever figure they have. When you circumscribe, that means that the figure will be outside. Figure is outside. The given one. And what we're going to be doing is we're going to be doing a circle. So if we have a triangle and we circumscribe a circle about it, the special thing about circumscribing are the vertices are on the circle. And that's true about any polygon. If you circumscribe a circle about a polygon, the vertices, every vertex of the polygon must fall in the circle. When you inscribe, and we're going to be inscribing circles, that means that the circle must be tangent or touch. Not a very good circle, not a real good picture, but you'll see when I start to do it. The sides of the triangle or sides of the hexagon or whatever we're doing. So those are the vocabulary words we're going to be using. So inscribing a circle and a triangle using compass and straight edge. Hopefully you have your equipment at this point in time. The end center of a triangle is a point of concurrency of the angle bisectors of the triangle. So I need you to associate the word end center with angle bisectors. And remember, we talked about point of concurrency yesterday. That's where many segments intersect at the exact same point. The end center is going to be the center of our inscribed circle. So if we're going to inscribe a circle, we are going to need a center and we are going to need a radius. So there's two major steps. To find this end center, you are going to bisect two angles. 2 will be sufficient. Then to find the radius, we are going to need an altitude. And you'll see this in a minute. So there, that altitude word is back. So here are step-by-step instructions. It says bisect 2 angles of the triangle, mark the point of intersection of these bisectors I. Using point I and one of the sides of the triangle, you are going to do the perpendicular construction from a point outside the line. This was the happy cyclops, or the, let me think. Well, we'll do it. Mark the point of intersection of this perpendicular and the side of the triangle P. Then the segment whose endpoints are I and P, you're going to connect that. That is the radius of the inscribed circle. So you'll put your compass point on I, you'll put your pencil point on P because that's the endpoint of the radius, and it should be tangent to all 3. Now, don't get too frustrated if you're off just a tad, because literally the thickness of your pencil point or the inaccuracy of your angle bisectors could cause it to be off. All right. So the first step we're going to do, and I'm going to get rid of that because I've got my line tool, is I need to bisect 2 angles. So if you recall, to bisect an angle, we put our compass point on a vertex, and you can use any opening you want, and then we draw an arc that intersects both sides. Then we're going to bring our compass to one point of intersection, and we're going to do an arc, keeping this same opening. We are going to come to this point of intersection, and we are going to do another arc. All right, so what we want to do, and this is, we want to connect this vertex and pass it through that point of intersection of those two arcs. The more accurate this is drawn, the more accurate your circle will be in your inscribed in your triangle. So again, a goal is to get our circle inside the triangle. It's going to touch all the sides. So now I'm going to put my compass point on another angle of my circle, and I'm going to draw an arc. So I'm bisecting this one. I'm doing the same construction I just did, except for another angle. So I'm going to do this arc. I'm going to flip it so we're over here. And maybe there we go. So now I'm going to do another arc. All right, I'm going to move this out of the way. I'm going to go from this vertex, pass through that point of intersection. And what we have just found, this is an in-center right there. That point of intersection is the in-center. Now, when I put a big point there, I've made it large, and that can get things off. So I've got the center of my circle, but now I need to know my radius. At the perpendicular segment from a point to a line is the shortest distance. All right. So this is where we have to do our perpendicular. So this would have been point I in my instructions on the previous page. So this is where now we're going to put our compass point on our in-center. And this is where we have to make sure that our opening is beyond that side. And so now we're going to draw in the smile. Then I'm going to come to this point of intersection, and I'm going to draw an arc. Then I'm going to move to the other point of intersection of that smile, and then the accuracy counts. We'll see how good this is in a minute. And now I'm going to draw that. All right. So all I truly need is to connect. Well, I'm going to go start here, and I'm going to draw, and maybe what I'll do is I'm going to do this with a dotted line. I'm going to start here, and I'm going to stop there. Now, the part I need, the radius of my circle, is from here to that side. So I believe in my directions on the previous page, I talked about that being point P. So now to inscribe our circle, we're going to put our compass point on the in-center, and we're going to get my compass opening. This is going to be my radius right here. So I'm going to see if that, how well my point is. No. So this is either going to be a little bit big or a little bit short. I can't get exact. All right. So now what I'm going to do is I'm now going to draw a circle. Wow, that's way off. So that should be tangent to that side. And I do not know where I went wrong there, because that's a pretty big outside piece. All right, so I bisected this. That looks pretty accurate. This does not look like it was bisected very well. That actually looks better. So somewhere I must have adjusted my compass a little bit. So I'm going to try this again. Do I have another picture? All right. So I'm going to do another triangle. Maybe I'll do, and I don't want a dotted triangle. Maybe I will do an obtuse triangle. All right. And again, it matters. The accuracy matters. The sharpness of your pencil point matters. So let's see if I can do better here. All right, so I'm going to bisect this angle. All right, I'm going to put my compass point here. And I'm going to rotate. I'm going to put my compass point here. And I'm going to rotate so I can draw an arc. And I'm going to put my compass point here, not change it, try to be as accurate as possible, do another arc. And I think what I'm going to try to do is I'm going to draw this line. All right, you know what, I need to probably draw that longer. Oh. So let me extend this line through that intersection. All right, so now I'm going to do another angle. And I think I'm going to choose to do these arcs. I'm going to open this up a bit. You don't have to, but I'm going to try to get these arcs up here so it's not inside my triangle. So there's one. And I'm going to come over here. And here's the second one. And I'm going to connect these two from here to there. So this is the center of my circle. All right, so now I either do a perpendicular to this line, a perpendicular to that line, or a perpendicular to that line. And I think a perpendicular here is going to be easier. So, only because it's wider. So I need to get out of the line tool. All right, so I'm going to put my compass point now on my end center. I'm going to make this has to be over that halfway, or not over halfway, but over that line segment, and I'm going to draw my smile. All right, so now I'm going to put my compass point here, and I'm going to open this up so it doesn't run into this line. I'm going to put my compass point over here, and I'm going to do another arc. Well, I barely made it. So now I'm going to connect this end center, and I'm going to use a dotted line, this end center with this point of intersection. And what I need from this, I'm going to put my compass point, I don't need a circle. I'm going to put my compass point on my end center, which is right here, and I'm going to put my pencil point then on my point of intersection of my perpendicular. So I think I'm going to go ahead and mark this because that is perpendicular. All right. Now that's what it's supposed to look like. All right, and I will be grading this based on your angle bisectors, on your perpendicular when you do this. You can see that this went off a little bit because I'm limited on how much I can adjust that compass, but I'm pretty darn close. So if you have something that looks like this, then pat yourself on the back. Job well done. Now that's inscribing. Now the circumcenter of a triangle is the point of concurrency of the perpendicular bisectors. Of the sides of the triangle. Circumcenter, perpendicular bisectors. You need to be able to associate those two. The circumcenter is going to be the center of our circle, and now the circle is going to go outside the triangle. You're going to like this construction better because it doesn't require that you have an altitude. All we need are perpendicular bisectors. All right, so circumscribing a circle about a triangle, you're going to construct the perpendicular bisector of two of your sides. You're going to label the point of intersection C, You're going to place the compass point on C and your pencil point on any of the vertices of your triangle, because that's going to be the radius of the circumscribed circle. Then you're going to construct a circle. And I will, when we get there, I'll explain why that works. All right, so we don't want that, we want this. So here is my triangle. Now, if you do an obtuse triangle, make sure it's in the center of your paper because your circle is going to be really big. All right, so I need a compass. And you all know that the perpendicular bisector is the fish. So that means you put your compass point on one vertex. You make sure your compass is over half the length of the side. Make one large arc. Then we're going to put our compass point on the other side. I should say the other point, vertice, and we're going to do another one. And so now we're going to draw in this perpendicular bisector. This is not a median because I didn't connect it to the opposite vertex. This is just a perpendicular bisector. All right, now I'm going to do the same thing to another side. I believe that is over. And then I think that's over half. I'll find out in a minute. I don't know, I think that's a little bit. Oh, I barely made it there. All right. So now we're going to connect these two. And where they intersect is going to be the center of my circle. So there's my point of concurrency. I put my compass point on the point of intersection, and I put my pencil point on one of the vertices. All right. If you remember, every point on this perpendicular bisector is equidistant from these 2 points. Every point on this perpendicular bisector is equidistant from those 2 points. So the point of intersection is equidistant from them all. And once you do that, then you get your circle, and it touches all 3 vertices. So if you want to see a YouTube video, then there is the website, and you can watch someone else do it. We're going to inscribe a hexagon and an equilateral triangle and a circle. All right, this is a really cool construction. So the first thing, the first thing we need, we need to construct our circle. All right, we need our own circle. We cannot start with one. All right, so here is my circle. Now, without changing my radius, that's key. I'm going to start right here. And I'm going to put my compass point on one point of the circle. And then what I'm going to do is I'm going to go, I notice I did not change the opening. It's got to be the radius. There's 1. Now I move to that point of intersection. And I'm going to open this a little bit bigger. There's 2. I'm going to come up here. And I just keep marking these off. There's 3. There's 4. There's 5. And there's 6. All right. If you were going to do equilateral triangle first, if you want an equilateral triangle, then what you do is you start on one arc, skip one of the arcs, and connect it to another. Skip, you go every other one. Connect every other arc. That is your equilateral triangle. And notice it doesn't want to connect where I need it to connect. All right. Well, you get the idea. Your pencil's more able to do this. For some reason, it wants to jump. All right, so that's an equilateral triangle. And I want to mark it equilateral, meaning all 3 sides are equal. If you want the hexagon, then what you do is you connect every arc as you move around the circle. And this is a hexagon. Not only a hexagon, it's a special hexagon. As you can see, there's a little bit of issue there. This is an equilateral hexagon, meaning all the sides are equal. There. Pretty easy. All right, so what I'm going to do is I'm going to do it one more time. So I'll do a smaller circle. There's my circle. There's my circle. Now, keeping that radius, I'm going to mark a point. So I'm going to start here, and I'm going to go around the circle 6 times. Even if you want to do an equilateral triangle, you've got to do the 6 because you have to do every other one to connect. There's 2, 3, 4, 5, and this should be my 6th one. If I come over here, this should intersect my little blue, which it does. All right, so now if you want the hexagon, you connect every one of these arcs. Make sure you mark the sides congruent. And then if you want the triangle, you're going to do every other one. I like these. All right. If we want to do a square, inscribing a square means we start with a circle. We need a... All right, so I'm going to redo this. And I need to know where my center is. So I'm going to start here and do my circle. All right. So what you want to do is you want to draw a diameter. And I think I'm going to make my center a little bit larger. That's my center. And then you're going to want to do a perpendicular. We need a perpendicular at that point. So by the time we're finished with all our constructions today, we will have done every type of perpendicular there is. All right, so we're going to open up my compass point on the point. We do an arc on this side. We come over here. We do an arc on that side. And now we're going to come over to this point of intersection. And I'm going to open my compass wider so it's up here. I'm going to do an arc, keeping this same opening. Go to that point of intersection, do another arc. So now I'm going to draw a segment from here through that point, and it should intersect till I reach to the other side. So now our square is going to be found literally, let me get a solid line, is going to be found by literally connecting these 4 points. If you recall, if the vertex is on a circle, then the angle equals half the arc. So if you notice, it cuts off 180, so that's 90. We've got vertex on the circle. Again, that's 180, therefore that's 90, and you can do the same thing, so we know that all of those are 90-degree angles. And then we know that this is perpendicular. It's actually a perpendicular bisector because this is the center of the circle, which means that segment's equal to that segment. So this point means this distance equals that distance, and that distance equals that distance, and same here. So that's how we get the square. And that is the end of the lesson. Your homework is a worksheet. Let me do one more because I did this the other day. This is part of your project. This is a big piece of your project. Remember that Thursday of next week, Wednesday of next week is when your project's due for feedback. And unfortunately, that's the only day next week I'm available after school, but I am available before school. So suppose we have a circle and we don't know where the center is. How do we find the center? We draw two chords in our circle, and we do the perpendicular bisector of each chord. And this might make sense. I could tie it into what we did today. What I just did is I did not construct, I just drew an triangle inscribed in a circle. So if I do two perpendicular bisectors, if you recall when you inscribed, let's see, when we circumscribed a circle, we had to bisect two sides, the perpendicular bisector of both sides. And it was that point of intersection that gave us the center of our circle. So we really don't need that segment. We need two chords. So I'm going to go from here through there. Now I'm going to do the same thing over here to this chord. I need I need to bisect this segment. And I'm going to switch it over here. And then I'm going to connect from here to here, and it just so happens that there's my center right there if I needed to find it. And you need to do that for your project. And you got 3 problems on your homework.